It's good. Okay, so the question is, on the back side of page 22, estimate how much smaller is the moon than Earth. You can give me a number, an approximation compared to something else. About 10 seconds. All right, turn to the person sitting next to you and discuss your answer. Well, can you slide it this way, smidge? I just want it all the way on the table if we could. Thank you.
I put the moon smaller than Earth because the moon is very small. What'd you put?
I don't really know. I put maybe 3/4 of the time. I think maybe like a 1/6 or 1/8 really. I'm pretty sure it's about the size of America. So.
About the size of what?
Its diameter is the size of America. So.
Alrighty, so
Thanks for responding.
Ashton, tell me what Jordan said. Oh, look.
Jordan said that the moon is 7 times smaller.
7 times smaller than the Earth. Okay, awesome. Okay, tell me what AJ said. 1/3 the size of Earth. Okay. Tell me what Courtney said.
She said that the basketball was the moon and then the basketball hoop was the Earth.
Avery made that connection too on page 23. Okay, about that size, and we're going to use that model as an example of what we're going to do today. Okay. What did Leah say?
That the moon is
20 times smaller than Earth. Okay. And then what did Liz say?
Liz said it's less than half Earth. The moon is less than half the Earth's size.
Less than half the Earth's size. Okay, great. So what we're aiming for today is you are actually going to build a scale model of the moon. So we're going to compare, the scale model of the moon to the scale model of the Earth, so we can actually see the size of it. You guys deal with scales. You've probably dealt with scales in art. Do you remember an assignment where they had you grid out a paper and then you had to draw a picture in there, and it was probably scaled down? So, one box here represents one box on the bigger thing, on the bigger picture, or it could even be like a still life that they set up for you if you were looking around the room and you wanted to draw a scene from the room. You would block it out, and then the blocks on your picture, you would draw it to scale. So that's one way to scale it. You guys deal with that when you deal with maps. How many of you have used a scale on maps in like geography? Everyone should raise their hand because you've done it before. Let me refresh your memory. Okay, on this map here that shows the whole globe, they've got a scale where 1 inch equals 379 miles at the equator. So it does that at the equator because the equator is the only true, the true to scale. As you go further north or further south, the map is distorted because of the way we have to lay it down, okay? Because of the way we flatten it. So when it says that 1 inch equals 379 miles at the equator, it means that, this space here represents 379 miles. And then this space here represents 379 miles, and this space represents 379 miles. So to figure out this distance here, we could technically measure it, find out how many inches it is, and multiply it by 379. Okay? And that would be to scale. All right? This is just a smaller model of the actual size of Earth, and it's supposed to be the same. If you could copy down these vocab words on the back side of page 22. All right, so your vocab words are scale model, scaling factor, and ratio. See if I can get a good image of that. Ish. All right, so a scale model's definition: copy of an actual object, only smaller or bigger by a certain ratio. And a ratio is a relationship between objects. So one can be bigger than the other. That's a relationship. How many of you have ever seen an Ertl toy tractor, like a model tractor? Yeah, those things are to scale. Usually they're 1/32 or 1/64, which means that they took an actual tractor, they did all the measurements, and they reduced it down by dividing it by 64. So everything is to scale. Everything is reduced down by the same amount. All right. Scaling factor is the ratio of the real size to the model size. So I'm going to teach you how to find the scaling factor so that you can apply that scaling factor to any real world thing and reduce it down to its model size, to a ratio. And so we're going to take a look at basketball hoops and basketballs. Cool? All right. So what we have here is an actual basketball hoop and an actual basketball. Huh? I'm going to give you some information that I'm going to have you write down on the board. Oh, I'm sorry. I'm going to write down it on the board. You're going to write it on page 23. Thank you. No, next to the hoop will be fine. All right. What we're going to do is we're going to measure the hoop distance here. Okay? Anybody know the regulation size for a hoop off the top of your head?
46 centimeters in diameter.
Pockets.
According to the paper.
You got it. 46 centimeters. Yeah. Okay. So you wait off to the side. You can write 46 centimeters. We'll get to writing this on the board. You just want to kind of watch. On your model, if you could draw a line from one edge to the other edge, and then use your ruler to measure it. So go ahead and measure the hoop, not the ball. We're on 23. We're on page 23. Page 24 is another way to do it, but I'm going to teach you this way first. And then if you want to extend yourself, you can go ahead and look at page 24. But we're on page 23. All right, so use your ruler and measure from edge to edge on the drawing of your hoop. How many of you don't have your rulers? I have rulers back there. Go. Were you supposed to keep them in your binder?
Yeah.
Yeah. Well, centimeters. Sorry. I didn't look at it close enough. Make sure you got centimeters. All right, so what are we aiming at? Ish.
5.5.
5.
We're gonna go 5 centimeters. Yep. So if you want to label that line as 5 centimeters, that would be awesome. All right, we're not going to measure the basketball. I'm going to show you how to figure out the scaling factor and then calculate it mathematically, okay? Because I don't know if this is really drawn to scale, so we'll check it later. Okay, and then we need to know one more piece of information. What haven't we measured?
Circumference.
Oh, what? We have this diameter, and we have the diameter of the hoop. What are we trying to find? We're going to find the diameter of the basketball. So let's measure the real basketball. This is how you do it. You want to pay attention to this because you're going to use the same thing when we do our model earths, okay? So there's a mathematical way to do it using a piece of string and measuring the circumference and dividing by pi, all that fun stuff. We're not going to do that. I'll show you the cheat method, right? And it's not, sometimes it's not very accurate, but I'm going to do this. And I'm going to do this. I'm going to measure here. We're going to go with 23 centimeters. Okay, you can write that off to the side because that's not the model. So, what we do know, we know the real hoop diameter. And what is that again?
46 centimeters.
46 centimeters. Okay. And we know the real basketball diameter. And what was that again?
23 centimeters.
23 centimeters. And we know the drawing hoop diameter. What is that? 5 centimeters. Okay. And we want to know the drawing basketball. Okay, diameter. So that's our question. And we also want to know the scaling factor because we're going to calculate one more thing using the same scale, using the same ratio. Cool? Good? Okay. So I want you to think about it like this. By the way, you have all of this written down on your paper, yeah? I'm going to add some things to my labels because they'll help me with my math. So my drawing hoop diameter, I'm going to put a D behind it for drawing. And I'm going to put an R behind my real things. It just kind of helps me separate stuff out. Okay? So think about it like this. And you can add the D and the R's as well. Five centimeters in my drawing is equal to 46 centimeters in the real world. So for every 5 centimeters on my paper in the drawing, I know that in the real world it equals 46 centimeters. Now a scaling factor tells me how much 1 centimeter on my drawing is worth in the real world. How do I get that answer? I see 3 people, they got it. Put your hands down. Keep in mind, you know how to do this. Let's give other people a chance to think through it. So, I want to make it equal to 1 centimeter in my drawing. How much does 1 centimeter in my drawing equal in the real world, and how do I get there? Just think about it. need to sketch things out or jot things down on your paper to help you think through it, you can. So now raise your hand if you have an idea of how we get that down to 1. There's more people. I got 1, 2, 3, 4, 5. See if we can get 10. I got 6, 7, 8, 9. One more person willing to take a risk. See how we can get that down to 1. Michael Shaw, I love how you raised your hand, so I'm going to pick on you. What do you think? Divide. Perfect. What am I dividing? 5 and 46? Okay. Divide 5 by 46 or divide 46 by 5? Yeah, okay. So, right on. Yeah, this is how we're going to do it. Check this out. This is why I use units. In my science brain, like, I have to use units to see this happen. Before you divide it out, I'll give you a chance to write this down. Just watch what's going to happen. It's like magic. All right? So I got this, and then I got this. Okay? And so these will cancel each other out, and this will be my scaling factor. So my scaling factor is, okay, 46 divided by 5. What is that answer? What did you say?
10.2.
Oh, you already got your calculator out. Do you believe her? She do it right?
No.
All right, 9.2. Now check out what happens with these units. We've got centimeters in the real world for every centimeter in the drawing. That line could also mean per. Okay, so 9.2 centimeters in the real world per every centimeter on your drawing. So go ahead and copy this down. And then I'm going to add this number up here so that I've got my things clearly labeled out. So 9.2 centimeters in the real world per centimeters in the drawing. Oh shoot, that's the scaling factor, I'm sorry. Does everybody have this equation down? Raise your hand if you don't. Okay, so I'm going to go ahead and erase this. Now, if I want to find the diameter of the ball in the drawing, what do you think I'm going to do? Why don't you talk at your table?
You're gonna want to know 22 centimeters by 9.2, because that's a scale factor.
Yay, Matt!
So the real one.
Yeah.
Because the ball is half the depth. So that means in the drawing room, the ball is still half the depth.
Okay, which groups have the answer? You guys do, you guys do. You're still thinking about it? Oh, the question is, how do I find the drawing basketball diameter? What do I do? Absent late work, redo. Okay. Kaylin.
You take the real divided by 9.2.
Okay, so I'm going to take the real basketball diameter, 23 centimeters in the real world, okay, and divide it by 9.2 centimeters in the real world per centimeters in the drawing. Another magic trick. Check this out. Wait, I know you're all on your calculators, but hold on a second. Check this out. if I'm dividing out my units, okay, I'm getting rid of this one, and they cancel out, and what I'm left with is my answer, which should be centimeters in the drawing. Ta-da! So this is going to read, okay, what is 23 divided by 9.2?
2.5.
2.5? Okay, centimeters in my drawing. So if it's 23 centimeters in the real world, and we use our scaling factor to determine our our drawing of the basketball, 2.5 centimeters. Logically, does this make sense? Does that match up? Go ahead and draw a line through your basketball in the drawing. Label that 2.5 centimeters. And now someone tell me the relationship between the diameter of the ball in the picture and the diameter of the hoop in the picture. I heard you guys discussing it. Yeah, you guys got it. Okay. So, Nolan?
The ball is half the size. The diameter of the ball is half the size of the diameter.
Yeah, does that make sense? Okay, and then check this out. So diameter, if we're doing this, does that match? The diameter of the ball is half the size of the diameter of the hoop. Anybody surprised by that? No? You can check it mathematically too. So the real hoop diameter is 46 centimeters. What's half of 46?
23.
Yes. That's that. Now, one more challenge for you. Using the scaling factor, we're going to draw the height of a person on here. Who's the tallest in the class? Oh, no doubt. Stand up. Here we go. Okay, come over here. Guesses?
6 foot.
6 foot.
6 foot.
6 foot. All right, turn around.
I already know.
But we're not doing it in feet. Oh, I'm sorry. Like this. Here. We're not dealing in feet or inches. What are we dealing in?
Centimeters.
Not yards, centimeters. Okay, so we're going here, and then
54.
oh my gosh, I'm not wrong. We're gonna say 178 centimeters. Good job. 178 centimeters. So here's our deal. Now, we have the real Landon. Owen? Ian. The real Landon. What did I say? 178 centimeters. Okay, that's real. All right, and everybody have this written down. We want to know our drawing of Landon using our scaling factor. So, go ahead and discuss with your table partner how you would lay out that equation.
178 divided by 9.2.
What would that do?
178 divided by 9.2.
Yes, you can use the spot on page 23 to show your work.
So just take a few inches off the top. Oh, no, now these 100.
I don't know. Can't be 9.2.
What did you do here? Right? You guys know what to do. Okay, so in order to find the scale drawing of the basketball, what did we do? We wrote it down. We wrote this measurement divided by this. So what did you do? Scaling factor. Okay, so to find Landon's height on paper, what do you do? Yeah. Yes. It will be for anything in this drawing. Yes, Sam?
What if it's a really large
It's incorrect. No, it's correct. I'm sorry. We're gonna go out 1. We'll go out by 10. Okay. All right. What did you do? Someone want to tell me what you did? Courtney, what'd you do?
We divided 178 by 9.2
Okay, 178 kittens.
centimeters.
Centimeters. Okay, and that's real. And you divided it by what? 9.2 centimeters in the real world per centimeters in the drawing. Okay. And what answer did you get? 19 point what? 3.4. We'll just go with 19.3. Okay, awesome. So, 19.34 kittens.
Centimeters.
Yep. Centimeters in the drawing. So I want you with your rulers to go from the bottom of page 23 and measure up 19.3 centimeters. So take your ruler, place it at the bottom at 0 for centimeters. We're not using inches. And you're going to measure up. You're going to draw a line, and you can label that line Landon. You could even draw a little head and then a body, stick body underneath that. And maybe put his hand like reaching out to the basketball. You want a model? Here, come on up, model. Nice. Okay. So does that make sense to you to see that measurement on there? Is that proportional? Is his head about where it should be on your paper in comparison to that 2.5 centimeter ball? That's lovely. I draw a hand out here holding the ball. You can draw him palming it if you want to. There you go. And then he is palming this one because it's for the scale. Okay. Thanks.
What?
So now, yeah, go ahead and turn it this way. Let's talk about Damoon. Damoon. Okay, so did you all write down the equations? How to do that? Because we're going to do the exact same thing with our scales. Okay? Our hoop is going to be just like the real diameter of the earth. And our basketball is going to be like the real diameter of the moon. Except we're going to use scaling off of this one. Right? So there are some things you know, and there's some things you need to figure out. So let's talk about what we do know and what you don't know. On the back of page 22, do you have room to write? Find a page, maybe the back of 23 for you. Everyone else, the back side of page 22.
How much are we talking?
A half a page. You'll need the rest of that page. All right, so we are going to need to know certain things to create a scale model of the moon. This is going to be just like figuring out what our drawing model of the basketball is. So we're going to use the same procedure. So tell me what we do know, Earth and moon wise. Yes, ma'am.
The moon is half size. No, that's the basketball.
Yeah, the basketball hoop is half the size. You're right. Let's talk about what we know about the Earth and the moon. Yes, ma'am.
The moon orbits the Earth.
Okay. Tell me about size. What do we know? AJ?
Moon is smaller than you.
Yep. Give me some specifics. Yes, ma'am?
The moon is about the size of the U.S.
Specific. Do we know the size of the moon? Serious? You don't know the diameter of the moon? Nolan, do we know the diameter of the moon? We do.
Yeah.
All right, so here, real moon's diameter. wrote this down on page 21. Yeah? 22?
22.
Yeah, you found it. Everybody else needs to find it. 22? You got it? Who else has the real size of the moon? You found it. All right, Kaylin, tell me what it is.
The diameter,
Yep.
3,474 kilometers.
Thank you for the kilometers. Good unit use. Okay, so we know the real moon's diameter. What else? What else do we need to know in order to make a scale model of the moon and the Earth? Yeah, we need to know the real Earth size. How do we find that out? In 30 seconds, how do you find that out? Thanks, Race. Thanks, Leah. Yeah. Use your resources.
It's 6,000
Yeah, do the calculations. 12,756 kilometers. Thank you for that unit use. Awesome. Okay, so we know the real moon's diameter. We know the real Earth's diameter. What else do we need to know to make a scale model of the Earth and the moon? Okay, so the model moon's diameter. Yep. And then what else? One more thing, and we'll be ready to rock. Yes, sir?
Model of Earth.
Yes. Okay. So our model Earth diameter. And you guys can find that out, right? Okay. And you have written down how to find scaling factor. And you have written down how to use scaling factor because it's the exact same example as the basketball. Here's what you're going to do. You're going to think about how well you understand this procedure. And you're going to think to yourself, am I ready to rock this alone? Can I do this alone? Do I need some guidance? Or am I really lost? I'm not really sure what's going on. Okay? And I'm going to ask you to put yourself into one of three groups. Okay? The first group, you're ready to rock it. You're going to go off with a group of other people. You're going to work through it together. You're going to find it. You're going to check your answer. And then you'll just simply tell me, the diameter of the model moon is this. Bam. Ready to go. The second group, you might just need some guiding steps. So me as a teacher, I'm going to say, okay, guys, what do we know? What's the first step? What are you going to do? Yes, that's correct. Go for it. Or no, that's not. Why don't you try this? Then I walk away. Then I come back and check your answer and say, okay, what's the next step? What do you think it is? Yep, that's it. Ready, go. Okay, so kind of stepping you through it, but then leaving your group to be on its own. The third group, I'm going to sit down with you and I'm going to say, first we do this. Then we do this. Then we do this. Then we do this. You'll be working with the group this whole time, so you don't have to worry about like doing it completely alone. And you'll be checking each other's answers and talking through it. So take a second and think about where you want to put yourself. Don't underestimate yourself. You have all the tools you need to be able to write up these equations using those numbers. So don't underestimate yourself. All right, so the group that wants to go off and do it on their own, you're going to go to that back table. If you want some assistance from the teacher, you're going to go to that table. If you want me to walk you through it step by step, you're going to come over here.
Do you want to end the video?
Yep, you can. Thank you very much.